Hi learners, welcome. In this video I am going to explain different types of hybridizations and how to assign shapes based on the hybridization. Even though this molecule undergoes the same type of hybridization, depending on the number of lone pairs present on the central atom, the shape of the molecule may differ. That's why here I am going to consider both hybridization as well as number of lone pairs, and based on that how can we assign shape for each molecule. Okay, let's see. First one, according to Vesper theory, we know that there are different types of hybridizations. So minimum 2 orbitals should undergo hybridization. So one s orbital and one p orbital. Whenever one s and one p orbital undergoes hybridization, we'll get only one geometry, that is linear. Linear means you can assume on this way. Okay, so two atoms in this molecule will be attached in this way in a linear fashion. Next, second type of hybridization is one s orbital and two p orbitals undergoes hybridization and gives sp2 hybrid orbitals. Total 3 sp2 hybrid orbitals. And in this case we have to consider how many number of lone pairs are present. Suppose if there is no lone pair, means 0. Lone pair is 0. Then the shape of the molecule is trigonal planar. Trigonal planar. Example, you can take BF3 like that. Okay, this is the shape of trigonal planar. Whenever it has one lone pair, here at the number 0 means no lone pair, 1 means single lone pair present on the central atom. Then see, here there are 3 positions occupied by 3 atoms. Here one of the position will be occupied with a lone pair. Whenever lone pair is present, it won't contribute shape to the molecule. That's why you just remove this part, then it becomes bent. Okay, whenever there is a lone pair, the shape of the molecule becomes bent even though it undergoes sp2 hybridization. How can we write this? Okay, bent molecule. Similarly, third type of hybridization is sp3. Means one s orbital and 3 p orbitals undergoes hybridization and gives 4 sp3 hybrid orbitals. Whenever you say again there is no lone pair on the central atom, then what we will do? We will get tetrahedral geometry. We will get tetrahedral geometry. So, example, you take methane. Methane is an example of molecule which is having tetrahedral geometry. Okay, and if there is single lone pair, means see one of the position, this atom should be replaced with a lone pair, means you need to consider this position, then it becomes pyramidal. Okay, the shape of the molecule is becoming pyramidal. Example, ammonia. You can take ammonia. X, one X will be backside and one more X, and it has one lone pair on the central atom. Okay, the shape of the molecule, even though here it is undergoing sp3 hybridization, it is also undergoing sp3 hybridization, but they are having different geometries. Similarly, there is a chance to have two lone pairs also. Then in that case, the geometry of the molecule, you can see one more position just replace with a lone pair. Then what happens? Just remove this. It becomes bent. Okay, the molecule shape will be bent. Okay, 2 atoms where it has 2 lone pairs on this. Okay, that's, and if there is a single, 3 lone pairs on the central atom, then it becomes linear. 3 lone pairs, then the shape of the molecule becomes linear. Means you can write AX. How many lone pairs are there on this? 3 lone pairs are there. Okay, so in this way, even though the central atom is undergoing sp3 hybridization, there is a possibility of having different shapes. It may be having tetrahedral or pyramidal or bent or linear. That's the reason why you have to see how many lone pairs are present on the central atom in order to give geometry of the molecule. Okay, so coming to the next one is, I will explain here. Fourth one, sp3d. Okay, sp3d. So in sp3d, if there is no lone pair, means 0, then we will get trigonal bipyramidal geometry. See, trigonal bipyramidal geometry. Okay, and these three are said to be axial atoms, and these two are said to be equatorial atoms. Okay, now if there is, what is the geometry name? Trigonal bipyramidal. If there is a single lone pair, okay, so in this case lone pair has to be placed in axial position, okay, in any of these three positions. When, for example, I am placing here, then what happens? You see, it is just looking like seesaw geometry. So geometry of the molecule becomes seesaw. Seesaw geometry. How it looks like? A, X, X, and it has a lone pair on it. Seesaw geometry. And when there are two lone pairs on this, so one more lone pair you have to place in the axial position. Let's say here and here I am placing. You can see the geometry of the molecule is becoming T shape. Okay, T shape. You can write T shape of molecule as A, X, 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 and it has two lone pairs on it. It has two lone pairs on it. And furtherly, there are three lone pairs. Then the shape of the molecule is becoming, see, one more position you just avoid this one, then it becomes bent. How many lone pairs are now on central atom? There are three lone pairs. Three lone pairs. And if there are four lone pairs, then one more position you have to remove, then it becomes linear. So the molecule shape becomes linear. There are four lone pairs now on the central atom. Okay, in that way you see there are 5 possibilities for sp3 hybridization. There is a possibility of having trigonal bipyramidal geometry, seesaw geometry, T shape, bend shape, and linear. Okay, now let's see the last one, that is sp3d2. Whenever sp3d2 hybridization, generally we say whenever there is no lone pair, octahedral. Octahedral geometry. With the general example I am explaining here. A is the central atom. In this case, A is the central atom. Okay, and when one of the atom is replaced with a single lone pair, there is a possibility of having a lone pair. So then generally here first lone pair occupies these are the positions, these positions. So now just remove this position. What is the geometry? Square pyramidal. How can we write this geometry? It's a square planar and one atom is above the plane. Square pyramidal. Whenever there are two, it has one lone pair now. Whenever there are two lone pairs, so another position here also we have to place lone pairs. Then you have to forget about this shape. It becomes square planar. Square planar. Then the shape of the molecule will be this way. This is the shape of the molecule, and there are two lone pairs on the central atom. Whenever there are three lone pairs, then what you have to do? One more position should be occupied with it, and then the shape of the molecule becomes T shape. How can I write this? How many lone pairs are there in the center? case now 3 lone pairs we have. 3 lone pairs. So whenever there are 4 lone pairs, it becomes, you remove this position also, it becomes bent. But in this case there are 4 lone pairs on the central atom. Okay, and furtherly if there are 5 lone pairs, the shape of the molecule becomes linear. So in this way you have to assign shape of your molecule based on its hybridization as well as number of the lone pairs present on the central atom. Okay, hope you guys understood this topic. Thank you for watching this video. Please subscribe to my channel.